Okay, so now I want to make the time series chart. So for that, just use our UI dot chart dot image dot series. Okay, so basically this is the function we already use lot of time, this function. And now I put all of argument one by one. So I already make the image collection 417. And now I want to make it, just put the curly bracket start as well as also curly bracket end. And then image collection mainly how much image I want to use for making this time series chart. So here I already input total 417 images, and these 417 images store it in a variable. Okay, so just write this variable name. So in this time, this variable name is data set. So simply copy the data set and paste here. Then region. So in this time, which region you want to make this time series chart? It can be a specific rice cultivation area, or it can be a specific boundary. Okay, so you can put any study area or any geometry. In this case, I want to apply, suppose I want to need this result for Dhaka city boundary, or you can put any specific boundary. Okay, it's totally depend on your study area, which area you want to observe. Suppose I just simply import my study area. So let's simply import, and I put my geometry name as a ROI. Okay, and I want to make this time series chart for my region of interest of Dhaka city boundary, which I store it in this variable as a ROI. So just put here that ROI. Okay. So now reducer. So in this time, reducer, we already know about that. You want to calculate the maximum density map between this time period, or minimum or average. So which you want to need. So simply write the reducer as a. Suppose I need the average this data. So put here e dot reducer dot mean. So now we find out that average time series chart of nitrogen dioxide. And scale is mainly resolution of your satellite imagery, which is 1113.2 meter. X property, so default as we just use here system time start. Okay, so basically this type of argument we simply input in a function, and then just take a variable name, suppose chart. Okay, and further, if I just run the code, suppose just print the chart and click to the run. So now we can easily find out this result in here. We got this type of result, time series chart. And from here, we can easily get it when the high, when the low concentration. Okay. So here you can see we got this type of result, but this chart have a problem. Okay. So if you check the value, you can see it show about that 0. Okay. So every value show as a 0. Okay. It show the null value. Okay. Every time show as a 0. So now how I can fix the problem? Okay. But it has a value, but in this time when I make this type of chart, the chart show as a 0. Okay. So now how I can fix this problem? For fixing this problem, unit. In this case, the chart created on mole per meter square unit. Okay, and it's very less value. Okay, per day we find out the very less value. So that's why it shows as a round figure 0. But when I convert it into micromole, then we find out the some value. Otherwise, when I just keep the mole per meter square and then I check, then we got the very less value. In Google Earth Engine, it shows as a round figure 0. So now this value I want to convert. So in this time, this value I want to convert. So you can see this data set mainly show the result in mole per meter square. But in this case, mole per meter square is not work, because this value is very less for my study area. So that's why in my chart, I find out it shows as a 0. But it has a value. When I convert the unit into mole per micromole, then we can easily find out the value. Okay. So now I will show you that how we can easily convert to mole to micromole and then find out, make the chart again. Okay. So if you simply search on the Google, suppose I simply search mole to micromole, then you can see basically when you just multiply the amount of substance value, 1 is 6. Okay. Or basically this is the value. When you multiply, then we find out the result in micromole. Okay. So when you multiply this value, then we got the result mole to micromole. Okay. So now we try to just multiply this value, then try to make the chart again. Okay. So now how I can multiply? Okay. So in this case, we need to apply this multiply all of images. Suppose 417 images, I need to apply all of images at the same time. Okay. So for that, we have to use the concept of function. Okay. We already use a lot of time for function. Okay. So in this case, we just make a function. And in this function, my argument is that I need to multiply 1 into 10 to the power 6, this value multiply, and then apply all of images. Okay. So let's try to make a function. So we already know about that, how we can easily make the function. For the function, just take a variable name. Suppose I put the variable name is that micromole. You can put any name as a variable. Equal sign, then function keyword. Then put the function keyword and put the element name, suppose img, and then use this curly bracket. In this curly bracket, I just put what is my argument. Okay, hear me? Hello, can you hear me? Okay. Okay, now it's okay. So suddenly electricity is the gone. I hope now it will be right. Can you hear me? Hello.
Yes, you are audible. You are audible, sir.
Okay, thank you. Okay, thank you. Okay, so we continue again. Yeah. Okay, so now in this case, we are just need to multiply. Okay, so just I simply put my argument. So in this case, my argument is that I need to multiply this value. Okay, so for the just take a variable, just I put here the return this image multiply with 1. I put the number. Okay, just I put here this value, just multiply this value. Okay, so now I just keep only for the one element, but I multiply just one image, but I have also rest of other images. So for that, just use the copy properties function. Just put here the copy properties function and apply the image, and it apply from system time start to system time end. Okay, so now I create this function. So this is the function. So this function I need to connect with my image collection. Okay, which is 470 image collection. For connecting this image collection, simply copy the data set. Just copy this variable name and paste here, and then use the map function for connecting. Okay, so now further, when I make the time series chart, just I use this new after multiply, which I got the data set. Just I use the data set and then check the result what we can got. So click to the run. If now check the chart from here, we got this type of value here. You can see we find out that the concentration value now it visualized. Suppose you can see it show the 130.99 micromole. Okay, so now we convert the unit micromole, then we find out this type of value. Also you can see the 327 micromole. Okay, 155 micromole in the 5th January. Also you can see the 6th January 198 micromole, and it show the average result. Okay, and we find out that this time 605.941 micromole in January 21. Okay, you can see this result. Okay. But first time it not show the value, it just show as a null value or 0, because it show the null value because now we find out the very less value. Okay, in the mole per meter square unit, we find out the very less value. So that's why in Google Earth Engine show as a round figure 0. But when I convert into micromole, then we can easily find out this type of value. You can see we can easily find out that this type of value, and it show the average result. If you want to check for minimum concentration, so simply put here that mean Just put here the mean. Then I got the result for minimum concentration for each day. Click on. So now it represents the result for minimum concentration. We can easily get it, this type of things. Okay? For each day, what is the minimum? And if you want to print the minimum maximum at the same time, just use this function mean max. Click the run. So now at the same time, it represented the minimum and maximum concentration result. We can easily get it for nitrogen dioxide for our study area. Okay. We find out this type of value. And further, if you want, you can simply download the data as a CSV file. Or if you want, you can also write the mainly legend title or X level, Y level title or chart title and represent it. So I hope you already know about that, how we can easily add this type of things. Okay. So basically, this is the process to working with the time series chart. Okay. And this time series chart sometimes not work, because when you want to work for the big study area, then the chart is not work. So further, we need to download the data as a CSV file. Okay, today's session I'll show you this process, how we can easily download the CSV file directly in Google Earth Engine. Okay, now I want to suppose visualize our study area. Suppose I want to show the map, and from this map I want to visualize where the high density of nitrogen dioxide, where the low density of nitrogen dioxide, I don't visualize. So now I want to make the map visualization. So for doing this thing, just take a variable. Suppose in this case, I want to visualize, suppose average concentration of nitrogen dioxide density. So just I take a variable, suppose average NO2, then equal, and now call the data set. So basically I want to make the average, suppose I want to use the micromole data set, because I convert into micromole. Now when I make the map, then my map unit will be micromole per meter square, because in this case I want to use this micromole data. Okay, same number of images we can also get in here. Just in this case, just we simply multiply with this value, just converting the unit mole to micromole. Okay, just copy this micromole and I want to paste in here, and I want to calculate suppose average. Just put here the mean, and further clip with my study area, which is ROI. So now visualize this study area. So just add the layer. So map.add layer and call this average NO2. Okay, just paste. And also focus the center of this boundary shapefile. So map.center object. Object is ROI. Suppose zoom level I put at the 10. Click run. So now it directly focused on our study area and also visualize this type of map. Okay, it shows the white color. So further we also try to add the color or color plated. For that, just simply click on this edit layer properties, and then suppose stressing 98%. And further you can add the color. So you find out this type of range. When I just put the stressing 98%, it automatically take this type of value. And now I want to add the suppose this type of color for low, greater than, suppose I put this type of green, greater than, suppose this type of yellow color, and high concentration I want to visualize as a red color. Okay, and then apply. So now this map is ready. We can easily get it from where is the high, where is the low. We can easily get it from here. So in this case, we find out this type of map. Okay, so we can easily find out this type of place. We find out that high concentration of the nitrogen dioxide, and this type of place where the low. It's the moderate or high, but it's a very high. Okay, and further we also try to export this map as a GeoTIFF file format. Today's session will show you that how we can easily export as a GeoTIFF file format, and then also work with the ArcMap software. Okay. Okay, so now any question, please ask me. Any question? Yes.
Sir, I have a very fundamental question, sir.
Please.
Sir, this time series chart, basically we can draw with the collection of images, or individual image is required to make a chart.
Okay, so in this time we find out that 417 images but all images have not value. Okay, so in this time it creates that only for this these have value, just take this type of data and then make the chart. Okay, so in this case we find out that 417 images, but all of images have not value. Okay, so when I export the CSV file, then you can check it. Some region we find out the zero. Okay, it show the null value, and this data set basically time wise. Okay, suppose in the 1st January, in I got the value in the suppose 8 p.m. Okay, and other times there is no value. Okay, so that's why this data set only for this data set we find out the in this time here you can see, if I just open this chart, we got only for the 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, we find out the 30. Okay, 30 data. Okay,
Right.
from 1st January to 30 January, or 31 January, we got the data. But other, we find out that so for this region, in my image collection, it will be just 30 images, but it show the 417 images. Okay,
Okay, sir.
so just you
Okay.
take the data only for that and create the chart look like that. Yeah,
Okay,
please.
sir.
Yeah. Any question?
Sir, I have a question. So basically, when we see this short area, short vision map, and in this map we can see the uh, color gradient like a grid. So how can, sir, how can we clear it?
Okay, so basically there are a lot of way to remove this type of grid. Basically it depend on the resolution. In this case, this resolution is very high, so that's why when I apply it for the small study area, then I face this type of problem. Okay, just suppose when I apply this map for the whole country boundary of Bangladesh, then this type of grid or cell is not visualized. But when I apply it for the small study area, then I find out this type of things. So for that, it also another solution. We can also create the smooth map just to extract the value. Okay, suppose just extract the value, and then further we apply the IDWI technique. Okay, so mainly interpolation. So I just a minute, I will show you this process. I already make a tutorial about that. Basically, when you apply this type of things for the small study area, we face this type of problem. But after creating this map, after creating, suppose I create this map, so now I just take the some value. Suppose I take the one value from here, I also take the value from here, and also take the value from here, I also take the another value from here. Suppose I take the total 5 values. Okay, so I find out it's a very high value, we find out it show the low value, and it's a medium or moderate value. And after that, if I make the interpolation, mainly IDWI technique, then we find out the smooth map. And in the IDWI technique, just we keep as a 30-meter scale. Okay, then this type of grid style will be removed. Okay, and we can get the smooth map. But if I use the raw data, so in this time, in this we just use here the raw data, mainly which data I want to get from here, just I use in here raw data. But when you apply this type of IDWI technique, then you also get the smooth map. Okay, so just a minute. First, let me open this tutorial. IDWI. Okay, so you can see this is the one we use as the creasing method, or if you want, you can also apply the IDWI technique, then you also get it. So you also try to watch this tutorial. I hope you can also get the some idea how we can easily create. Otherwise, you can see this red color show as a grid. Okay, this is another grid. This is another grid. Okay, but when I just apply the creasing method, or interpolation creasing method, then we find out this type of map. Okay, this type of final map we can create. Okay, so basically some data, some satellite images have the very low resolution because this pixel size is very high. Suppose this type of data, when you want to work for the chart satellite data or other types of data, that the very very high resolution, or ER5 data set. Okay, this data set is very high. Suppose if I check you the another data set, I simply search here. Suppose ERA. Suppose this type of data set, if you want to check what's the resolution, we find out that you can see. Okay, 27,830. So now if you just use this data for your study area, suppose Dhaka city boundary, so one, we find out the grid only for one or two grid, this type of grid. Okay, this type of grid we find out. Okay, this is the one grid, this is another grid, this that, with this type of grid we find out. But I want to create the smooth map, this type of smooth map, so that type of grid or pixel is not visualized. So for that we are just applying the creasing method, and then further we check get the smooth map. Okay, so it just extract the pixel value. Suppose you can see it create the lot of point, this type of point, extract the pixel value from this type of cell or grid, and then create this type of smooth map. Yeah, please. You also try to check it. I hope we can easily get it.
Okay, sir.
Okay.
Sir, this clicking is applicable in ArcGIS, no, sir?
Yeah, it also possible to applicable in Google Earth Engine also. Okay, creasing or IDWI. ArcMap is also okay, but we can easily apply in things in the Google Earth Engine also. Okay, basically this type of data set. Okay, when I apply in my small study area, okay, then we can easily apply and then get the more smooth map. Yes. Okay, anyone, any question, please?
Yes, please. What if I wanted to convert to parts per million ppm?
Which one?
The nitrogen
Yeah.
dioxide,
Yes, yes.
the conversion.
Sorry, cannot understand your question, please again.
I want to convert instead of molarity to parts per million ppm.
Okay, parts per million, yeah, ppm. Okay, so it also possible.
Yeah.
Suppose we have to just, okay, I'll show you that further how we can easily convert this type of unit. Suppose ppm or ton per meter square. So this type of unit or change we can easily do it, no problem. Okay, I'll show you that later. Just a minute. Okay, so now any question about this code, you can ask me. Okay, for any confusion, for any things, you can ask me. But we can easily convert ppm or ppb, parts per billion. Okay, we can easily do it, no problem. Okay, any question, anyone? Okay, so basically we are using the software GeoTip, mainly it's possible to ArcMap or ArcGIS as well also QGIS. Okay, both of software you can easily use software use, and then further you can also make the map. I will show you this process also. Okay, I hope that is my question. Yeah.
Could you send us the link to the code, please?
Okay, I will send you all of code, no problem. So after completing the class, I will send you all of the code in our Google Classroom. Okay, you can easily get it. Google Classroom also. Yeah. So now we find out this type of imagery for my study area. But when I apply it, suppose I want to apply it for my big study area. Okay, suppose I want to show the result for whole country boundary of Bangladesh. Okay, or any study area. Just I simply import, okay, this is study area, and remove my previous one. So it not need, just remove. And I put this variable name, suppose as a RY. Okay, now run the code. So now if I run the code, we don't find out this type of grid or cell, because now it just fixed with my study area. Okay, that's why we don't get this type of grid or cell. But when I apply this type of data for the small study area, then we got this type of grid or cell. So now you just stressing, suppose. Okay, so now put here this, suppose just run it, and just import this color also in my code. So it added the new color. So simply copy and paste after the object name. Just paste. So now it will set it. So now we got this type of map. Okay. So basically in the middle place, we find out that high concentration of the nitrogen dioxide. Also get some also high in here. Right. So this is the map year of 2024, month of January, for the whole Bangladesh. Find out. Okay. Further, we can easily export this type of map, and we can also work with ArcMap or QGIS software to produce the final map with map layout or other things. Okay. Okay. So this is the process to working with this dataset. And if you want to visualize the other data, suppose here you can see it also some other data. You want to visualize, suppose methane or ozone, just apply the same process. Okay, just apply the same process. Then we can easily visualize for the methane or sulfur dioxide. Also, suppose ozone. Okay, formaldehyde, carbon monoxide. Okay, when you want to visualize and make the time series chart, just apply the same process which I show you in here. Okay, so this is the process to make the map. And now I will show you that how we can easily download the data. Okay, suppose how we can easily download the data in CSV file. Okay, so when you want to apply the CSV file in your data, so in the CSV file mainly we find out the two column. One column show the time, another column show the value. Okay, so just I will show the example. Suppose one column show the time, another column show for value. Okay, suppose first January, it show the value, suppose 0.12 mole or micromole. Okay, second January show the value, suppose for 0.25 mole. Okay, so this type of time series chart we can easily generate in Google Earth Engine, and further we can easily directly download the data from here, because sometimes chart is not work. So further we are just applying this type of creating the time series chart directly from Google Earth Engine, and then we can easily take the chart from the Excel file. Okay, so in the chart, first of all, we need to create the two column. One column suppose time, another column suppose value. Okay, time mainly show the image acquisition time. Okay, and value mainly for image, what's the value I can got. For this image, what the value I can got. Okay, so now we try to discuss about that. So just take a variable. Suppose I put the variable name is that CSV. Okay, and we create a function, and I put the function name, suppose image. So in this time, what is my argument? My argument is that using this element, I want to calculate the value, as well as I also want to make the image date. Okay, for image acquisition date. Okay, so for that, just take a variable. Suppose put the variable, suppose stat, and I put here image. From this image, I just extract the value. So for extracting the value, we already use the reduced region function. So basically this function extract the value. Okay, for it can be minimum, maximum, or average. Which value you want to need, you can simply mention in here, and then we can easily get the value. So just I take a variable stat, and I want to extract the value from this image. So just I call the image and put here the reduced region, and then put here all of argument one by one. So here you can see, just I make a dictionary, and also close this dictionary. And reducer. So reducer mainly I put here, suppose I need the result for average result. I want to download reducer dot mean. Okay. Then geometry, it's your shapefile variable name, which is suppose ry. And then scale is the resolution of your dataset, 1113.2 meter. And others not, remove that. Okay. take a variable and then simply call the element name of this image and then use the reduce return function and just we extract the average value. Okay, so it's one column. Okay, suppose value column it's complete, and another column we also need for that date or time. Okay, and this date is also come from this image. Okay, because for the same date we need to also extract from this image and then put here image dot date, and date is a number, so this number we convert as a string. So for that use here the format function, basically format this function convert number into string. Okay, so just we create the two variable stat and date, and then we are put here the calculate the mean as well as also extract the date from here. Okay, so now further we try to make a dictionary using the date and stat.